Identify the phases represented by segments R and T on the heating curve. A heating curve plots temperature on the vertical y-axis against heat added on the horizontal x-axis. The diagonal segments correspond to the heating of a single, stable phase of matter, while the flat horizontal plateaus represent phase transitions occurring at a constant temperature. Since the sample starts as a solid at 100 Kelvin and is heated continuously, segment P is heating the solid. Segment Q is the solid-to-liquid phase change, melting/fusion. Segment R is heating the liquid phase. Segment S is the liquid-to-gas phase change, boiling/vaporization. Segment T is heating the gas phase. Therefore, segment R represents liquid ethanol and segment T represents gaseous ethanol. Recall the thermodynamic relationship for heating a single phase. The quantity of heat, Q, absorbed by a substance to change its temperature, delta T, is given by the calorimetry formula. Q equals mc delta T, where m is the mass of the substance and c is its specific heat capacity. Analyze the mathematical definition of the slope on this heating curve, rearranging the calorimetry equation to express the temperature change, delta T, as a function of heat added, Q, yields. Delta T equals 1 over mc. Q, since the y-axis is temperature, T, and the x-axis is heat added, Q. The slope of a heating segment is defined as slope equals delta T over Q equals 1 over mc. Relate the slope of each segment to the specific heat capacity. See the mass, m, of the ethanol sample is constant at 50.0 grams. Consequently, the slope of a diagonal segment is inversely proportional to the specific heat capacity, C, of the phase being heated. Slope is proportional to 1 over C. A steeper, greater, slope means that less heat is required to raise the temperature of that phase by a given amount, which corresponds to a smaller specific heat capacity. Compare the slopes to find the correct relationship. The problem states that the slope of segment T is greater than the slope of segment R. Slope T greater than slope R, therefore 1 over m times C gas greater than 1 over m times C liquid, therefore C gas less than C liquid. This proves that the specific heat capacity of the gaseous ethanol is less than the specific heat capacity of liquid ethanol, confirming option A as the correct answer. The correct answer is option A. The specific heat capacity of the gaseous ethanol is less than the specific heat capacity of liquid ethanol.